Okay, I'm starting a new series that I call Office Hour Recap. Okay, so today is Monday 23rd, 2020. So one of the questions that I received during my office hours is this. Okay, in this question what we did was we gave area 1 is given, force is given, and area 2 right over here is given. Okay, and I am being asked to find what my P1 value is. Okay, and what I also highlighted here are the information that I don't know. Okay, I don't know my V1. Okay, I don't know A3, I don't know my V3. Obviously I'm assuming that this is symmetric, there will be only one outlet over here, not two outlets. Okay, so you can see I have three unknowns. Okay, so if I go ahead and draw my control volume in the orange color that you see over here, let's see what I know, what I don't know in order to obtain my P1 value. Okay, first I will solve the conservation of mass. And if you look at it, you will see that I don't know my V1, I don't know my V3, I do not know my A3 if I establish for this orange colored control volume. Next is to do the conservation of momentum in the x direction. Okay, if I go ahead and do it, what you will find out is on the left hand side there will be a P1A1 that is on my free body diagram, so the P1 is not known. Okay, also V1 will be there, which I do not know. Okay, and that's it. I do know my force, A3, V3, so the V3 is perpendicular to the x direction, right? It's in the y direction, so I don't have to worry about that. That's not quite an unknown. And you see here now I get four unknowns. Okay, so you can see that I'm getting into a trouble place, right? What I can do is I can do the conservation of energy in the form of Bernoulli's equation if you want to. Okay, and then what you will get here is this time around your P1 will be unknown, P1 will be unknown, your V1 will be unknown, your V3 will be unknown, and what else? That's it. Okay, because it's open to the air, so I know the pressure there. Do you see where I'm going with this? I do have 1, 2, 3, 4 unknowns, and I have 3 questions to solve for them. So I can really solve this equation if you go through the standard procedure. And I will show you the hint for these kind of problems, how you should attempt to solve them. Okay. Now what you can see here is I changed the control volume from 1 to 2 control volumes. So basically I divided it into 2. This is one of the oldest tricks in the book. If you have more unknowns than the equations available to you. Okay, and also I would like you to note that in the original question I was given the A2 information right over here, right? I never used that. Okay, that's not an alarm. As you may remember in my midterms as well, I sometimes give additional information just to see whether you will be able to work with it as well. Okay, that's something to note. So now if I divide this into 2, let's see what will happen in here. Obviously I do not know my V2. Okay, so I add actually one more unknown to my case. Okay, V2 is the unknown. So if I write the conservation of momentum for orange color in the x direction, what will happen is you will see that I know my F. Okay, right now as you see there's nothing contained inside of a pipe. I don't have to worry about the pressure forces, so that's good. Okay, V3 and A3 are unknown. However, if when I write my conservation of momentum in the x, they are going to be perpendicular. The velocity 3 will be perpendicular, so they will not be playing a role there. And you see here that the only unknown that I get is V2. Okay, so if I use my conservation of momentum in the orange colored control volume, I will be able to obtain my V2 value. Okay, for the red control volume, let's do the conservation of mass, okay, and see what happens in here. Okay, as you know, I do not know V1, so I know V2 now, I know A2, I know A1, right? So the unknown is V1, so I will be able to find this from the conservation of mass. Okay, and then in the red control volume I'm going to write the Bernoulli's equation. Okay, and basically, if you write the Bernoulli's equation, you will find out that the only unknown over here will be the pressure 1, okay? And because pressure 2 is jet, so it's not there, V1 is known, A1 is known, V2 is known, the gravitational changes, elevation changes can be neglected, so I will be able to obtain this question. Next question I want to discuss is this particular case. So what happens here is there's a flow downwards over here, and it goes all the way to down, right? So the area 1 is given, area 2 is given, and I'm being asked to find my volumetric flow rate, okay? So how should we approach this question? Number one, the step is basically to determine the control volume. And I have received few questions about this. You do not include the manometer into the control volume. The reason is that the manometer is a static pressure measuring device, so there is actually no flow going into this branch, okay? When you look at this branch, there's no flow over here. This is all stationary, and the control volume is for fluid dynamics, right? So for that reason, I'm not going to include that, okay? Now, let's write the conservation of mass. If I write my conservation of mass for my blue control volume, you will find out that I don't know V1, I don't know V2, okay? However, I'll get the relation between those two, okay? The next step is to calculate using the Bernoulli's equation, okay? Okay, write down the Bernoulli's equation to save some time. So you can see here that I do not know my V1, I do not know my V2, okay? This GZ1 and GZ2 terms, depending on how you set it, for instance, I can set my datum in here, then Z2 will be 0, and Z1 will be whatever that height is, okay, in the question that's given to me, all right? So then that's known, so these two are known. Now let's look at this P1 divided by density and P2 divided by density, okay? So what I'm going to do is I'm going to use the manometer to obtain P1 minus P2, or P2 minus P1, equal to the same, right? And once I find this from the manometer, I will just plug it into here. And the two unknowns that I have in this equation will be V1 and V2, okay? And as you see, in the conservation of mass, I have V1 and V2 as well. So basically, I get two equations, two unknowns. You can find your V1 or V2. We need only one of them, right? As Q is constant, then I will do V1A1 or V2A2, one of them. You will be able to obtain your Q value.